everyone for joining us today. Today I'm really excited because today we talk about security, supply chain, image signing, verification with a guest that from Google, and his name is I think Dan Lorenc. He's worked as software engineering at Google, and he did a tremendous amount of work in the Project Sigstore space. And hopefully we dig a lot deeper about what the role of Project Sigstore are. But let's go to my guest. Hi, Dan Lorenc. Can you introduce yourself to my audience? Where you currently living? What are your day-to-day planning these days?
Sure. Yeah. Thanks a lot for having me. My name is Dan Lorenc. I'm a software engineer here at Google in our security organization. So I've been at Google for a while now, but for the last couple of years, I've been focused on our supply chain security, particularly with open source. So I've been trying to figure out how to make it easier and safer for Google to consume and produce open source software securely without having to worry about supply chain attacks.
Yes, absolutely. And being dull to the security and these kind of things. So I want to know where you currently living, how COVID affects you, and these are the routine checks.
Great questions. Yeah, so I live in Austin, Texas. I've been here for it's a little over 3 years now. Before that, I was in the San Francisco Bay Area. How COVID affects me. Yeah, I think you can tell quickly from my profile photo where I haven't had a haircut since about the start, so February or March of 2020. So my hair is quite a bit longer now than it used to be. Don't know how long I'm going to let this keep going for, but if you're watching this, I look quite different from my profile picture.
Yes, absolutely. But I think you look pretty in this style, like beard and a long hair, because ever since I go to the Kubernetes and cloud native, I'm losing hairs a lot of time right now. So next obvious question. Every time I talk to the new guests from the Google, especially, you are the team who give us the open source tool that we love about, that is Kubernetes. And I think that, can you tell my audience, if you have Kubernetes, what sort of advantages we have? If you don't have Kubernetes at this point of time, what you lose in the future?
Oh man, that's a tough question. Yeah, so Kubernetes is complicated, right? It's a big piece of machinery. It brings a lot of complexity with it. There are a lot of ways to make it simpler to use. But it's still something that it seems like most companies and enterprises, big and small, are moving toward, which is nice. The reason I think it's nice is because everybody is doing it, right? It's giving us this unified control plane that everybody gets to work on and collaborate on and improve and rely on together. So if you run into problems with the complexity, like you probably will, there's going to be a million Stack Overflow and Google search results and people on Twitter that can help you, right? You don't have your own custom built thing that nobody else understands and can help you out with. And the same thing for containers in general. A decade ago, everybody was building their own Python applications and Java applications, and everything was a little bit different, and everybody used different setups of bash scripts to build and deploy. People had to solve a lot of the same problems on their own at their own company. Containers give us one standard way to package our code and deploy it and reason about it and store metadata and distribute that metadata and do everything. So it's a whole new ecosystem. There's a lot of stuff we still have to do and improve on, particularly in security, which I guess we'll talk about a little bit later. But it's nice that it's one ecosystem that everybody is building on and sharing today.
Yes, absolutely. And I think you can you just tell about your story of being to the Google company. That is a company behind the Kubernetes and Cloud Native Computing Foundation to the journal, and have a larger ecosystem of major tools. So what your journey into the Google and Kubernetes, and for the last couple of years, what you do and how you keep yourself busy with these technologies?
Sure. Yeah, it's been a long journey. Like I said, I think I've been at Google for about 8 or 9 years now, and I've been in cloud, the Google Cloud space, since pretty much the beginning, since before it was called Google Cloud. My first team at Google was on the App Engine project. If you're familiar with that, it was like one of the first platform as a service tools out there where you would just run a command and deploy your code, and it would serve traffic and scale, and you didn't have to worry about build or managing infrastructure. Sometime after that, the whole container world started take off. It was awesome. I remember using Docker, pretty early on, pre 1.0, when everything was still changing rapidly, and then the launch of Kubernetes, and that's kind of how I got involved in this space. There was no, so on Google App Engine and in our other cloud stuff, I was doing developer tools to make it easier for people to run and build stuff locally on their computers. As Kubernetes started to take off, I noticed there wasn't a real good, easy way to get a Kubernetes cluster set up for development. So I started the Minikube project. If you're familiar with that, it's the standard way to get Kubernetes set up and running in a VM on a MacBook on any kind of laptop you have. So that was my first, the first time I learned Go actually was the first couple commits on the Minikube project. If you look all the way back, it's pretty ugly, but it was there. So I worked on that for a while and kind of watched Kubernetes and everything grow up around it.
Yes, absolutely. And you draw very good points there. I'm really excited that you are a team behind the Minikube project. And that's a wonderful story, because when I seen the Kubernetes is adopted and being presented to the enterprise as the open source project, I try to compare this technology with the previously we have, let's say we call the VM technologies. When the VM first came up, they provide the compute capacity to us. And somebody, the open source like Linux are then bloated up in the space, like so many distribution of Linux every day coming up. And the people who are there in that time are really struggling their heads. What is happening in that space? So many Linux distribution, what to learn, how to install, how to configure, how to patch these kind of things. And the same stories happened when the Kubernetes came up. The distribution are blowing up like Minikube, K3s, K0s, so kind, so much. But when you started Minikube, how many distributions are there at that time? Kubernetes.
Oh, I can't even remember which Kubernetes release this was. It was a long, long time ago. Yeah, it was just when the cloud providers were getting started, so there weren't too many. There wasn't even on Google. There wasn't a real easy way to go and get a cluster set up with GKE. I think it was still really early on. You had to run a bunch of bash scripts to get Kubernetes set up, even in the cloud. So it's come a long way since then.
Yes, absolutely. And I think at this point in time, like August 8, August 20, there is so many distribution right now. And we see every day there is article on how to configure and set up your Kubernetes distribution like K3s, K0s. So there's a huge business and huge plus point to be adopting these Kubernetes. But I think today our topic is like the role and responsibility of first the Project Sigstore, but I think you are on the Google side of things. So I try to expand this question. We see that Kubernetes has SIG releases, like SIG projects or subset projects, like service meshes and networking, the Kubernetes interfaces, the storage interfaces, the networking interfaces, and then we have a security kind of things like Project Sigstore. So can you draw some point of my audience who are listening to this podcast? What are these roles in the Kubernetes open source communities like Project Sigstore or SIG roles? What are these SIG roles are, and what are they trying to do?
Sure. Yeah. So the different SIGs in Kubernetes, and so Sigstore is not actually an official Kubernetes SIG, and I can explain that in a little bit. But in Kubernetes, they do have things like SIG release, SIG infra, all of these things, and SIG stands for Special Interest Group there. And they're groups of people working on different parts that own different parts of the Kubernetes code base and different parts of the Kubernetes release process. Sigstore itself is actually a project for supply chain security. It's under the Linux Foundation, which is the same home that Kubernetes and the CNCF are. And we're working with the Kubernetes SIG release group to help secure their releases. But Sigstore is a little bit broader than just cloud native, a little bit broader than just Kubernetes too. The idea is basically to make it easier to understand where the code that you're running, whether it's in a container or a Python package or a Java package or binary executable you downloaded from the internet. The goal is to make it easier to understand where that code came from, who built it, how it was built, and all of that in a way that's free and secure and can help build trust in our kind of open source supply chains.
Yes, absolutely. Because I think right now is one of the questions that I try to ask myself and the person who I'm talking to. That the boundaries between this, what the developer do and what the operations do is blurring with the container ecosystem. Because on the same file, like Docker file we have, the infrastructure code plus there are so many things in that Docker file. You are not just writing code, but you are blueprinting your infrastructure. So there the boundaries are blurring at this point of time. I think these are the roles that they are evolve over the time. Their role is to provide the roles and responsibilities of what the developers are, what the operations team are, and then build the tools around that. So developer needs some kind of tool to work with Kubernetes, and operation teams need some kind of tool to work with the infrastructure. So I think these SIG roles are their primary role is to help adoption of Kubernetes and related these cloud technologies are really simple. So as I think we are, the topic is right now on the Project Sigstore side. So can you introduce my audience how Project Sigstore came into being? What are the processes involved that, how you came into being, what your roles are, and what us community are doing in Project Sigstore?
Sure. Yeah. So I'll tie the problem back to Kubernetes again a little bit and explain, some of the issues that we're trying to solve there. So everybody knows package managers, kind of have problems, and there's all sorts of old versions of packages in there that might have vulnerabilities and aren't secure, and it's a constant pain to update and figure out what versions of packages you're using. Right? This comes up with NPM all the time. Everybody knows about like leftpad and all these little packages that get used everywhere. And if you write a Hello World program, you have millions of lines of code, and there's all sorts of vulnerabilities in that. NPM is just one language, right? When you take a container now, you bundle up a whole bunch of operating system stuff like Debian packages or RPM packages or Alpine packages into a container. And then you throw like a whole bunch of NPM packages or Go modules or Python packages into there. And then when you go to deploy that to Kubernetes, you probably put it inside of like a Helm chart. So you've got a whole bunch of different containers. Each of those has a whole bunch of different dependencies inside of them, which have their own dependencies all the way down. So at the Kubernetes level, we've kind of shifted all that responsibility to the developer, like you said. In the old days, an operations team used to manage upgrading packages on a server, and the development team just kind of dealt with code. But now we put all that infrastructure into code. So development teams have to update all of their packages, plus all the operating system packages, plus all of the dependencies, and that whole tree. And that gets really hard to manage. So if you just take a container or you take a Helm chart, like an average Helm chart off of the Artifact Hub. I wrote a blog post, I think, sometime early last year about this. I took a random Helm chart off of Artifact Hub, and I just broke down every container in there and all of the things inside of it, and found like 37 different critical CVEs just from the latest version of this, because everything goes out of date. And it's not really Kubernetes or containers' fault. They just sit at the top of the hierarchy, right? You've got operating system, and then languages, and then containers and groups of containers and applications all the way up. And so they kind of inherit all of the vulnerabilities from everything underneath them. And we don't even know what's in them is kind of the problem. So that's how we started the Sigstore project. Right? Another example I like to use is here. I've got like a little flash drive, right? If you've seen one of these USB flash drives that you plug into your computer, right? Everybody knows that if you find one of these on the sidewalk outside of your office or your house, you're not supposed to pick it up and go plug it into your computer, right? Everybody knows this. All security teams warn people about this because there could be a virus on there, right? You don't know where it came from. But if you just run like npm install and a package name, for some reason that feels okay to developers, even though it's the same exact thing. You're downloading code from the internet, you didn't look at the code, you don't know who wrote the code, and you're running it on your laptop. It's even worse sometimes because you take that code and then you deploy it to production actually. The USB stick I only plug into my laptop, I don't plug it into a production server. So this is really scary from a security perspective. And attackers are using this all the time. There are tons and tons of vulnerabilities and malicious code that get pushed to package registries, just waiting for people to download and deploy so they can either mine Bitcoins or hack your infrastructure. So with Sigstore, we're trying to make it so that you can kind of automatically inside of your build systems generate kind of secure metadata explaining exactly what went into each package, each archive, each container. And then storing that in a big public transparency log. So anybody can look it up. You can type in the name of any package or any container and see exactly who built it and when and what source code went into that. So you can start to look these things up, and you can walk back the chain to figure out exactly what went into your code, what went into the code that went into your code, all the way back to the start of time.
Yes, absolutely. That's a wonderful information. I think you draw wonderful points on right now, because I think that right now what we do is we doesn't do like 10 years before. Like we doesn't think about where our code is running. We just write the code, and the operations team has this configuration to boot up the VM, then install operating system on top of it, then install dependencies that your application needed, and then you just throw your code on top of it. But that's not happening in container, because container is actually operating system layer plus bunch of dependencies, bunch of Linux, and the Linux have some kind of, yeah, because we, Linux is actually a isolation process. Container is actually a Linux and isolation process, control group and namespaces. So I think this is absolutely vital. And right now, the people talking about what are the first step I need to do in order to secure my runtime infrastructure. So I think the first question is to tell out what your dependencies are. Are these already secured? Because if these are already secured and you have some kind of tools in place, then the rest of the container and rest of the infrastructure is by default secure, because these are the same images that runs on different machines in the cloud, in the different laptops, in these kind of environment. So what I learned is that Project Sigstore is a project that has this kind of mindset that these are dependencies, and dependencies has its own vulnerabilities. Let's say that every time a new package came up, they might have solve some issues, but introduce some more issues with that newer version. So that's the Project Sigstore's ability to help minimize these risks when you are layering your images, because images are really a set of instructions, set of layers, and you want these layers to be secured, and you have a very good understanding. So I think the next question, the obvious question that I see from the tweets and other part of this, I see that Cosign is in the market right now and is have some kind of abilities to secure your containers. So can you introduce yourself to my audience, what Cosign is and how it helps us securing our containers?
Sure. Yeah, so Cosign is one of the tools inside of Project Sigstore. It's a tool for signing container images. So it uses cryptographic digital signatures so that you can kind of take a private key, you can make a private key and a public key pair, and you can sign a container image with that. So if somebody finds a random container image on Docker Hub or copied around to a mirror or running in their cluster, they can look up to make sure that the container has been signed by a person that they trust. So if you've seen containers and you kind of grab them by the latest tag, or you just grab a random one off of Docker Hub, you don't necessarily know if that was approved by your organization or if that was built by somebody that you know. It could be, an attacker doing some trick like typo squatting or dependency confusion, trying to get you to grab the wrong container image. So with Cosign, you can run a couple of commands and you can set up some keys, and you can use YubiKey or a cloud key signing service. And you can sign the images before you run them. And you can use that inside of something like Kubernetes or another environment to check and make sure that all the container images have been signed and approved before they're allowed to run in your production infrastructure. People make typos and screw stuff up all the time as they're editing YAML. There's a lot of code with Kubernetes. And so there's a lot of places that mistakes happen and people accidentally run out of date or vulnerable or malicious or just the wrong containers that they didn't think they were supposed to be running. So on Docker Hub, Bitcoin miners get taken down constantly, where people take like MySQL and they swap 2 of the letters, and then they put a Bitcoin miner in there. And so when you install it, you still get MySQL, but you also get a Bitcoin miner. And this happens all the time, and you always have to check and chase them down later after the fact. So Cosign is a tool that you can use to help protect yourself against those attacks.
Yes, absolutely. I think what I learned from your talk is that we have images that are stored somewhere else, like Docker Hub or GitHub container registry. But when you download it, you need to entrust that once you download it is from the official person, that the person you entrust on that. So the Cosign is a tool. So if somebody pulls an image, so you have to trust that this is a signing image is signed and is have a trusted party that you have to build on. So previously, I think before the Cosigns and these kind of other tools that already exist, we have to do some kind of public key infrastructure to build these kind of infrastructure ourselves. But literally, thankfully for the people like you, now we are relying on this third-party tool to that, because this is I think the whole community plus the whole enterprise is the first thing they need to know. What the image they are pulled on is actually the people they trust on. Because images are so many, and somebody, even I can pull the image on Docker Hub, and you can pull it down on your machine, but you need to know whose sign is and who are pushing these images to Docker Hub. So when you sign those images, you need to know we don't know each other, and we don't trust each other, and this way the chain reaction helps out a lot. So Cosign, Project Sigstore, so we delve into this. But I think the Project Sigstore, do you think, do I believe in the future that all these like Cosign, other tools are under the umbrella of Project Sigstore, if I'm understanding the right way?
Yeah, that's correct. So Cosign is under the umbrella of Project Sigstore. Yeah, it's got, like you mentioned, it's got public key infrastructure built in, so you can own keys if you want to, or use your existing PKI system, or you can use some of the other components from Project Sigstore, like our transparency log and our certificate authority, to use our public key infrastructure to make it even easier for you if you want to. A lot of that was copied off of the model of Let's Encrypt, which I'm sure you're familiar with. Let's Encrypt is the technology that makes it easy to get free certificates for the web browser. If anybody remembers what the internet was like before that, nobody had certificates because they were expensive, and you had to pay for them and get them from, these CAs that charged a lot of money, and you had to do it over email, and it was a pain, and people always forgot, and they ran out, they expired and stuff like that. So Let's Encrypt made it easy to get free ones. They rotated automatically, and they built all this awesome tooling and APIs, and now everybody just has certificates everywhere, and they don't have it. So our goal for Cosign is to do that same thing for container signing and make it easy for people to get free certificates that they can use to sign containers with their email address, and power that with all the rest of the components in Project Sigstore.
Yes, absolutely. So I think we cover a lot about the Project Sigstore and the Cosign process as well. So this is, I think, the part one, as we're wrapping up the part one of this podcast, and we continue to do these kind of things with Dan Lorenc, because he's a wonderful community person. Every time we talk to him on Twitter, I try to invite him for these kind of podcasts. He go elsewhere, talk about these kind of things, and help us understand these are the essential tools, because security, we can't rely on the third party. You have to know these tools and understand the proficiency of these tools, because containers are by default are not secure. You need some kind of things to be done. And also when you pull down the images from Docker Hub or the GitHub Container Registry, these are not by default secure all the time. And you need some kind of tooling. And thankfully, in the Kubernetes community and plus the Project Sigstore and these community are really doing put on a lot of energy, so we can have trust built in the image we are downloading in. So I think before I let you go, so what are the next plans for you in the Project Sigstore plus Cosign? What are the new version I think we're coming up? What are the initial version we have? What are the next capabilities are coming up in the future?
Yeah, a lot of what we're focused on now is making it automatic, right? It's easy to kind of manually sign and verify stuff now. But we need to make it automatic so people don't even need to think about it. We need to make it so build systems automatically sign your containers for you so you don't have to worry about it. And we need to make it so Kubernetes stops you from doing things that you don't trust automatically, so you don't accidentally make mistakes. And build systems like Tekton, and we're doing, publishing GitHub Actions and GitLab plugins and all of these things so that whatever CI system you're using just automatically vouches for the containers that you want to run later. And the same thing for admission controllers in Kubernetes. There's a whole ecosystem of things like Open Policy Agent and Gatekeeper and Caverno and a ton of other tools to help you make sure that you're only running containers you trust. So we're making it so that you don't even actually need to use Cosign to sign and verify your containers anymore.
Yes, absolutely. I think that's wonderful news for me, because right now, because I've been working in the service mesh space, and we see the sidecar is by default are mutually secured with each other. So I need, if somebody put on the stack on top of it, it's by default is absolutely doing the things without me tuning the button and ask these to verify and sign these images. So these are the best news, because in the CI system, who has this responsibility to click the button and then the verification process start? We want this to be every time and then chain reaction start. The first thing is pull the images, then it is have some kind, let's say Cosign is the person is the technology behind that, who was verifying and signing these imaging, and they built on the trust between the person who are pulling the images and person who put the image in the Docker Hub or the GitHub registry or any registry in the world. So this is a wonderful learning process for me, because I'm absolutely new to Project Sigstore today and absolutely new to Cosign. But in a shorter amount of time, I learned a lot, great deal about you. So this is our part one of the podcast, and we try to cover another supply chain, because we try to cover the whole supply of the security with the person we believe in them. We put on a wonderful knowledge about doing these kind of things, helping us learn these kind of technology. With the next podcast, in the part two, we try to cover, let's say, TektonCD and the CI/CD process behind the whole supply chain. But thanks for everyone who joined us today, and hope to catch up you again in another episode of cloudnative.fm podcast. And the next episode is once again Dan Lorenc with you. I'll be talking about the CI/CD process behind the delivery and the putting your code from the development machine to the testing to the production. It already secured by default. You have to tune the knobs. You don't need to tune the knobs of it. So thanks everyone. Hope you enjoy the podcast. Hope you enjoy the hairstyle of Dan Lorenc. I really enjoy it. So thanks everyone. Bye bye.
Thank you.